to another class with Mr. Sanchez, and today I'm going to teach you about tangents. And this is basically the basic principle of all calculus, right? Be able to find the tangent. So here, I have here drawn four graphs, and we're going to find the tangent at each x value, right? So over here, when x is 4, the tangent is going to be like that, right? So remember, the tangent is when it only hits the point once, and it has to be perpendicular to that point. See, for example, over here, it has to hit this point, and it has to be perpendicular, so it's going to be a horizontal line. Over here, has to hit only once, it has to be perpendicular, so it's like this. And over here again, the same thing, it just has to be perpendicular, and hit like that. That wasn't a straight line. Oh wow, that's bad. There we go. Alright, and so now that we know how to draw the tangents, we're going to figure out the equation to find the tangent. So to be able to do that, we're going to first draw a secant. Alright, so you know a secant is a line that just connects 2 points on a graph. So here I have my 2 points, and I'm going to draw my secant. That's my secant. Alright, so I'm going to give each point its respective x and y value. So our x value here is going to be c, and the y value is going to be, well, f of c. Alright, there we go. So then, oops, well, the x and y value over here is going to be a little different. So basically, alright, so the difference between these two, c, and whatever this number is, I'm going to call that delta x. Alright? So basically this x value, well, since this is c, and the distance between here and here is delta x, this x value will be c plus delta x, right? Kind of makes sense. So now the x value for this is going to be c plus delta x. And the y value is just going to be f of c plus delta x. Alright, so now we have x and y values of each point. So now to find the slope, you know the slope m is equal to delta y over delta x. Which another way you could write it is basically just y2 minus y1 over x2 minus x1. So we have our y2, y1, x2, and x1. Now let's just plug it in, or substitute. So f of c plus delta x minus f of c over c plus delta x minus c, right? So now we can simplify. You see that the c's will cancel out, and up here, well, nothing can cancel out. So it'll just be f of c plus delta x minus f of c over delta x. So now this is our slope of that secant line, right? So basically, the tangent though, we want the slope at c of c and f of c, right? This point right here. So how can we find the tangent? So basically, the tangent is going to be this slope as delta x reaches 0, right? So if let's say delta x gets increasingly smaller, right? So let's say that's the tangent line, or the next point. So then this is going to be the next tangent line. Here, the closer point is going to be this. Here, it's going to be that. Eventually, they'll reach the same point, and it'll just be the tangent line. Alright, so remember in the previous chapter we were learning about limits. So we can specify here that it's the limit as delta x approaches 0 of the slope, and that's our equation to find the tangent. So now that we have this, now let's move on to our problem over here. So this is a pretty basic problem simple problem, but we're gonna use what we figure out over here to be able to incorporate here to find our slope of the graph when c is equal to 2, right? So let's figure this out. So here we have our equation and we're just gonna substitute it in, right? So f of c, oh, remember, always write your equation, so f of c plus delta x minus f of c over delta x. Okay, so now the limit as delta x approaches 0. So now I'm just going to plug it in, right? So it's going to be 2c plus delta x minus 3. That's my first. So now minus f of c, so it's going to be minus 2, and c is equal to 2, right? Because they gave that, so we can just substitute that in all over delta x. We don't know what delta x is. Now let's just simplify. So the limit as delta x approaches 0, so 2c plus 2 delta x minus 3 minus 4 minus 3. Or you could say minus, oh wait, my bad. Here this should be 4 minus 3, so minus 1. All over delta x. Okay. I forgot to substitute here this 2, because c is 2, so it's going to be 2 times 2 is equal to 4. My bad, that was my fault. So now, again, let's simplify even more. And remember, you always need to keep this limit as delta x approaches 0. Because if you take it out, it doesn't make sense. I know it's a little tedious and you're like, why do I need to do this? But remember, it's very important. So negative 3 plus negative 1 is negative 4. And 4 and negative 4 cancel out, so you can take these two out. So then now we have 2 delta x over delta x. And now you can see, since they're multiplying, you can cancel the delta x's. So the limit as delta x approaches 0 is 2. So that's our slope. The slope when x is equal to 2 is 2. Of course, you could have seen this since this is a linear function and there's only one slope throughout. But this is just a simple problem, so you can use it in more different functions, just as a parabolic or a cubed or a circle, for that example. And so that is tangents and how to find the equation of a tangent. And so hope you like that video and have a good day.